my name's Brittany. I'm Tom's trusty assistant for this session. So it gives me great pleasure to introduce James McPherson. He is the principal software engineer. A principal software engineer, thanks, on the Solaris modernisation team at Oracle. So that sounds fascinating. I'm really looking forward to listening. So without further ado, I hand it over to James.
Thank you very much. Hi, my name's James McPherson. As Brittany said, I'm a principal software engineer. I work in the Solaris modernisation group within Solaris Core Technologies in the systems division. So I was part of the Sun acquisition. I've worked in, on and around Solaris for about 23 years, ranging from a user to a system administrator, doing technical support, escalation management, software development, gatekeeping. I'll talk about that in a bit. And new feature development. I'm based in Brisbane and my team is in Santa Clara. Voila. So our content slide. I'm going to talk to you about why we in Solaris love Python, and as well as where and how we make use of it, which is quite extensive actually. So firstly, why do we like Python? Well, you might think that operating systems are only written in what you might call a systems programming language, so C or assembler, and you're mostly correct. But what's really exciting is realizing that Python is actually a systems programming language as well. It's carefully and sensibly designed language, at least as far as we can tell. It's got a massive standard library, which is awesome, and I've been working with Python for a few years now. I had not scratched half of the library documentation, let alone any of the rest of it. We love it because it's fast to create designs in, fast to prototype, fast to test. We've got lots of testing frameworks available. It's really easy to integrate the testing frameworks, and that helps encourage us to be better software engineers along the way as well. Having familiarity with Python means we find it easier to integrate open source that people seem to like using these days, that our customers ask for and that we internally ask for, because open source in many cases solves needs that we have, and we, rather than writing it from scratch ourselves, if there's something out there already, we can use it. We've contributed back to the community through Python dtrace provider so that you can introspect inside your Python programs, utilities. We did that because we found it useful and realised others would find it useful. We've also built Python stack extraction capabilities into our debugger called MDB. It's the modular debugger. And if you run the pstack utility on a Python process, you can see where the Python process is, which it's just really handy. So, where do we find it? Where do we use it? Well, from the bottom to the top, and a bit off to the sides. We use Python commands to manage boot environments for our packaging and installation technologies. We have a full Openstack distribution. I'm not sure whether it's Icehouse or Havana. I lost track about the time when we were doing the mad rush for the 11.2 release about 3 months ago. And we've also got some random little utilities which are actually really handy, and we have them on our live USB distribution. Internally, we use Mercurial for the Solaris source code management system, and we wrap that in and around our internal build tools that we use to build Solaris from everything. So, hang on, I missed a slide there. Sorry, that's what it should have been talking to. So, how? Boot environments. Boot environments are how we ensure that you always have something that will let your system boot. They're based on ZFS, our revolutionary file system, and they're really cheap to create and to modify, destroy, test with. We have a utility to manage them called BEADM. Not all that good on naming things, it's fairly sort of, minimum. And it's in Python, written in Python, and we use C language bindings to our ZFS library, which lets us get into managing the actual data sets. It's really fast, really, really fast. And it's not just fast because ZFS is fast, it's fast because it's in Python. And it lets us do all those things that we really hate doing in C, like strings. Next, there's our packaging system. We introduced a new packaging system called IPS, an image packaging system, with Solaris 11, which came out in 2011. People who've used Solaris versions before 11 will know and loathe System 5 packaging and System 5 patches. We burnt that to the ground because it just was not appropriate anymore, and it had long since served its purpose. So, it's a complete redesign, and it manages the entire software lifecycle. So, apart from about 4%, which is in C, and that's highly optimized functions for our solver to give us actual correct solutions to what we want to install. Pardon me. The rest of it, about 220 odd thousand lines of code, is in Python, and that includes unit tests. So if you actually go and look at your installed Solaris system and count the lines of code, it's actually about 100,000, but that's neither here nor there. Yeah, it provides the consistent behavior that you actually need and want in order to have a maintainable system, have a supportable system, so you don't get a bit of this and a bit of that and wind up with something that is just hideous and really difficult to debug when it goes wrong. So I mentioned System 5 packages. We applied patches, and you could go dig into those and pull out just that driver or just that file that you wanted to apply, and things got messy. But with IPS, we installed new versions of packages, and it's all tested and nicely bundled up so that it all works, and we can guarantee that that works for you. We have a nice sort of marketing-ish picture here on the right, which gives some of the other benefits. It's networked. We have our repositories are all on the network, in part because they're so large now, and because we don't really want to have to wait to spin up DVD printing and post that out to people. It's all cryptographically verified. Tim, is it SHA 512 or?
So it's SHA1 at the moment, but we've got
pluggable encryption. Yeah. Tim there is one of the primary developers of our packaging system. We have a complete set of tools so that you can create and manage and distribute your internal applications. And we make it so that the best practice is the default practice and you can't stray off track. And we like to be able to say that this is one of the main benefits of it, which is that it works, and we know that it works, and you know that it works, so you can rely on that. This is the first of two picture-y slides. So here we have what software distribution was like with Solaris 10. We have file systems, volume management, packaging, patching, a utility to manage patches, and then the installation technologies up there, and that's all rather complex. And I never worked in our professional services team, which actually went and got this stuff happening for customers. But when those people would come and talk to me, they would just go, "Oh, it's such a pain. Isn't there something better?" And then with Solaris 11, I can say, yes, there is. It's here. Look how simple it is. Because we burnt that to the ground, and we're doing this instead. And it's so much easier, so much cleaner, logically, as well as code-wise. And then with 11.2, which came out on the 31st of July this year, we introduced something which we call unified archives. These are sort of built on top of what we had there with IPS and the distribution constructor, and that's our cloning system. So, but that's cloning for redeployment, cloning for backup, cloning for moving to a new bunch of hardware, or doing physical to virtual or virtual to physical. And it's easy to create, it's easy to store, it's easy to spin up again. really, really nice, I've got to say. Now, installation technologies. I've covered those a little bit. What we did with these, and one of the reasons that it was actually really quick for us to get unified archives developed, is because we reused the code that we'd built on top of IPS. So distro constructor for making our golden images, automated installer for doing hands-free installation. All these things, we built it on top of what we already had in IPS. And it's all Python, like distro constructor, AI, unified archives. It's all done in Python, which builds on top of Python. So we're going up the stack, and it's still Python, and it's still fast. And we're doing things faster because, we're doing code reuse. Good software engineering, nice and modular. These are some of the grab bag of utilities that you'll find. Though I wouldn't exactly call RAD, our remote administration daemon, a grab bag because it's just so powerful. Pardon me. So we have a device driver utility, which if you plug in our live USB, it will pop up and say, oh, you've got these devices. I've got a driver for that one, a driver for that one. Not sure about that. You'll need to check somewhere else, which is really handy if you want to go and test it out with a new laptop. We provide Python bindings for the ZFS command. So again, we can do strings in Python, essentially, rather than C. And we provide C, Python, Java bindings for our remote administration daemon, which it's kind of new. It's kind of one of those sort of lurking below the surface features, but it's going to get a lot bigger. And it's what we use for doing live migration of zones, kernel zones, non-global zones. We're just building and building and building in Python, with Python. We have a full distribution of Openstack in Solaris 11.2. And this leverages our technology. So it leverages zones and kernel zones for virtual machines. We have an elastic virtual switch. Please don't ask me about that. I don't know about that. I still haven't got my head around it yet. ZFS for the block storage. Unified archives for saving your image so that you can then spin it up later on one of your kernel zones, for instance. And we are, with our Openstack distribution, we are contributing our changes that we've made upstream, so everybody will get the benefit of those. And we're going to keep going with the cadence that Openstack goes with. So if we don't have Icehouse now, well, we will soon. If we don't have whatever the one starts with that comes next, it'll start with J, I believe. We'll have that too. And it'll be full implementations. We have quite a big and good team working on it. So, as we all know, it's Python from top to bottom. We're using this for our internal development cloud because it's easy to do, and it's good for us to help shake out problems along the way so that you don't see them when we ship it to you. It's just really simple. It makes sense. It works. It means that we don't have to worry about all sorts of things that a lab booking system would let you, or would make you have to worry about. You can just point and click and spin it up and away you go. So one of the beauties of our packaging system is that we manage dependencies. Limoncello is my workstation back in Brisbane. I connected via the VPN to our packaging server, which is in Santa Clara, in the top end of Silicon Valley, bottom end of the San Francisco Bay, and I downloaded the Openstack package. Now that Openstack package said, well, I depend on these 200 other packages, and I'll need to install those in order to make sure that I can say that I have correctly installed cloud/OpenStack. So it did that. And I timed it because, I like data points, across my wet string connection under the Pacific, 10 minutes to pull in, 55 megs. Not too bad. But that gave me a complete OpenStack distribution, which now it's up to me to configure. But I didn't have to worry about going and pulling in all the little bits from everywhere to make sure that I had them in the right spot. Yes. You could also do it with the Unified Archive. Now, I downloaded the Unified Archive file from oracle.com because it's convenient and you can do that. You just have to click accept on the license terms, so you're basically not from Syria or Iraq or, you know, places like that. Then I created the kernel zone. I added 2 virtual interfaces. The default kernel zone config is to have 2 gigs of RAM. I said, well, that's not really enough. I made it back at 4, just, you know, as an example. So it's one, admittedly, that's a bit of a sort of complex command line and not exactly obvious until you've played with Zone CFG a bit, but it was pretty simple to work out. I installed it and I booted it. Sorry, I booted it and installed it from my archive. And then I ran the zlogin. And on my Core i5 workstation, that took 7 minutes, a bit over 7 minutes to do. And then I had a complete working kernel zone, which is Solaris within Solaris, but it had all the OpenStack stuff in there. And I give the URL if you want to go and download it yourself. We make this very simple so that it's simple for you, so you don't have to worry about going and finding all the bits. We've done the hard stuff. So internally, this is kind of my favourite area, I guess. When I introduced myself, I said that I'd been a gatekeeper. So gatekeepers in the Solaris world, we are the system administrators who make sure that everything builds. So I had to get familiar with Mercurial, written in Python. Had to write gate hooks to prevent people from integrating changes that weren't authorized, to back out changes that were broken, to do certain database updates for the bug tracking system, to go and kick off incremental builds, a whole heap of things, which I had to migrate from shell scripts when we were using SCCS to shell scripts that were talking Python as well. We did a bake-off in 2007 between Git and Bazaar and Mercurial, and at that time we decided that the most appropriate source code management system for us was Mercurial. We actually went through quite a detailed process with lots of questions and requirements to get it right. Yes, so that's about how much code we've got for Solaris. What did I say? That's Solaris 11. Yes, it's 14.8 million lines. Each subsequent release, that includes 11.1, 11.2, and other development releases that are coming, have only increased that number of lines of code. The percentage of C is going down slightly, Python's coming up, but in terms of what you as a user or system administrator of a Solaris system would see, most of what you're seeing is the effect of being able to use Python for that. We had to migrate bug tracking databases after the Oracle acquisition of Sun. They gave us a breathing space until the end of Solaris 11, and they said, right, you've got to switch. You got that one out the door, now you can focus on what we want. And so, yes, written in Python, I used CX Oracle and CherryPy in order to provide a mechanism for our existing gate hooks to go and check, you know, whether you've got the bug in the right state and whether you've got this, that, and the other. And yeah, I actually wrote that. I learned a lot more Python and SQL than I ever thought I probably would. And I learned a lot more SQL than I really wanted to. But, you know, you got to do what you got to do because that's just the job. We have a Python marshalling script to control our builds. That's something I was involved with as well, but also more Tim. I started a project to completely redesign our build system, which was 25 years worth of craft in some cases. I said, we need some architecture and we need to replace the shell script, which is 5,000 lines of shell and not modular and not testable, and yeah, with something that actually works and that we can maintain. And I said to my boss, I need some help with Python. He said, how about talking to Tim? So a year later, we finally delivered, but Tim wrote this thing. And it's really good. It's really nice and modular, and it's about the same number of lines of code, but it's modular and testable and extensible, and it has unit tests built in. It is awesome. We have post-build checks that run, and they're all written in Python, and our packaging, our delivery to the release engineering people who actually get all the core Solaris and the userland stuff and cluster and Java and all the rest of it. The way we get that to them is in Python. And then release engineering has tools which are also written in Python to make all the packages, which then go to package.oracle.com. So, yes. We use Python in Solaris from the very top to the very bottom. We quite like it. Because we are using Python, because we made the decision to start using Python as our higher level systems programming language, we've actually been able to work faster and innovate faster and deliver that to you a lot faster. And because we can do that faster, you can do it faster. And because of the features that we are building in, like OpenStack, you can integrate our systems into your environment much more easily. And we are hiring Python programmers. Please come and see me if you're interested. So, what questions do you have? There's one up there. We just need to get a microphone to you.
I can't yell.
Yelling's good.
How did the decision to use Python come about? Was it driven top-down, or was it driven sort of bottom-up?
I believe it was
coming
more,
from Oracle/Sun, I would have thought there would have been a bit of a push to use certain other language.
My understanding, and Tim, I'll ask you for clarification, is that it was more organic, that people started experimenting with new things and thought, hey, this works quite nicely. What can we do with it? I've got an idea. How about a new packaging system? Or something like that. That's probably cutting out a few years worth of innovation.
Maybe I can comment. So the developer culture at Sun has always been engineering driven. It's really been from the bottom up, and it's sort of find the best way to solve all the problems that we have. That said, when Java came out initially, and this is back in the Solaris 8 and 9 days, we had an audio tool, like a little desktop controller that changed the volume. And by the time it took for that tool to start, the JVM boot and everything, we have kind of engineers quiet, and still waiting for stuff to come up. So yeah, that was a big bad use of Java. So there's certainly ways that good intelligent ways to use Java, but as a audio tool controlling volume control.
Wasn't the right tool for the job, but Python is. Another question?
Thanks, Sayers. I used to use Solaris a bunch a while ago, and at that time, the package management system was, like you see, like this complex maze of shell scripts.
Yep.
And sometimes I'd try and patch my workstation up to current, and it would take about 3 days, and then I'd fail to hit yes at the right time, and I'm in a bad state. So it's really cool that it's kind of advanced since then. I'm wondering, how do you contain the potential for, when somebody wants to install like a third-party library or something, and they want to use, pip install something. Potentially that could, since Python is now so tightly integrated into the entire system management, somebody could shoot themselves in the foot, that way.
Yep.
Are there some kind of orange cones or like something in there so you can make that a bit harder?
Yes. We've got the package command has package verify and package fix as subcommands. So you can, if you are at all worried about stomping on system libraries, you can run package verify and it'll say, oh, this is what we've stored as the features of this particular file or directory. This is what it is, and then it exits. And then if you want to fix that, you go package fix and then the name of the package. And for certain files, drivers, certain system libraries. If we need to fix that, if you say package fix, name of whatever, we'll create a new boot environment so that we fix it in there. So your running system stays up and running. And when you are ready, if you want to go back to, shall we say, pristine, you can reboot very quickly to the fixed environment.
Because it seems like, that sounds fantastic. I'm just thinking it might be, maybe that's something that a wider community could get at if you have this idea of, install transactions or something. You can like roll back a whole bunch of dependencies or something. That would be kind of nice to have.
Yeah. Cool. And we keep history as well, so you can see exactly what we did at any particular installation or update or whatever.
But can you go back to an arbitrary point in time? Go like, I can go back, last week before I installed all this horrible stuff.
As long as you haven't deleted the boot environment, yeah. My practice on all my systems, and I've got Solaris on my laptop in the bag up there, as well as all the boxes at home, is I keep 4 boot environments. I don't need to. It's just a practice I got into when I was the gatekeeper, because you needed to be able to go back and chop and change. We were running nightly bits then as well, so that helped. Yeah, as long as you've got a boot environment to go back to, and our customers do tend to keep them around, then you're fine. And if you don't have that one, then hopefully you will have installed it from an automated installation, so you've got the profile for that somewhere else, and you can spin it up again.
It's easy to compare boot environments as well. You can see so what changed between yesterday and today's boot.
Yeah.
That's a very cool feature. Yeah. Cool, thanks.
Yeah.
Any more questions? Yeah.
There's one. Yeah, at the back.
Sorry guys,
Uh,
last question.
So all this stuff is really cool, but going forward into the next 10 years, what makes Solaris a necessary operating system, aside, of course, from the existing user base? How do we justify the existence? What is this main selling point of Solaris as an operating system?
That's not a question I can really answer, because you need a salesperson to answer that.
That's true. That's true.
And I'm not a salesperson, I'm a kernel engineer. But what I can say is that we keep innovating, and we keep abreast of technology, we deliver new technology. We scale and scale and scale. Have you seen mention of the hot chips presentation that our systems division head gave a few weeks ago, where he was talking about our new systems, the M7. That's a monster in a box. Solaris scales to that sort of capability, and customers are buying that sort of capability. They're buying it now. They're going to keep buying it, and it's just going to keep getting bigger. So if you want to talk about massive multi-core systems, then we've got them. Yeah. Well, it goes from 1 core up to thousands. And I'm finding my laptop constrained because I only have 2 cores. I want to do more. I know the software can do more. My workstation at home with 4 cores can do more, but I need a new laptop. I want a new laptop. Subtle difference. So yes, all the utilities that you depend on. So your power, your water, your telco, your bank, government departments, they all run Solaris, and they have continued to run Solaris, and they are migrating back to Solaris because we can provide the scalability that they want and need, and in some cases that they didn't realise was available to them. So, but if you want more than that, then I can put you in touch with a salesperson.
No, I've got people on Oracle, so I'll just get them to...
Yeah. Yeah. So,
Great
right.
stuff. So please
Thank you very
join
much.
me in thanking James for an awesome talk.
Thank you. Sorry, one last thing. I've got some references if you want. When you go to download the slideware, those are links as to like our documentation pages and some blog posts and some man pages as well. So thank you.